Alright, we're back. Another massive amount of interruption. Now it's 8 o'clock now. So much for getting anything done today, huh? Okay, so I forget where I left off, but I got some cracks I got to deal with, obviously. I think we're talking about welding rod between hard, soft, and extra for a good. So I got 5556, 5356, and then 4043. So anyway, like I said, 4043 is doesn't shrink much, doesn't crack as much. It's not very strong. Sticks to just about anything. A lot easier. It flows better. So it's easy to use. The hard stuff, it's well, it's fairly good to me. It's a little bit hard to weld, I guess. I don't know. I'm used to it. And it's a lot more stronger, but it has heat cracking problems when it gets over 150 degrees on billet materials. So on the cast stuff, I don't think it matters. It works good. I've never had stuff crack after I weld it, so I've been welding it with years. So it works pretty good. So I did that head here the other day. How did I do with that damn thing? Yep, Scooby's gone. He was here earlier. What did I do with it right here? So this is the head I welded up. So this I used a combination of hard, soft, and extra hard, extra strong. Depends on what you're welding. So this here is an exhaust spigot. You got to cut round when you're done. So I use hard material on this because I want the machine. Soft is very gummy material when you go to cut it. So when you're filing, grinding, doing this with grinders, using files, whatever you're doing, sanding like that, it just gums up everything. It's just crappy material to work with. But it's fairly consistent on its strength, whether it's hot, cold, or in between, up to a point. So that's why most people use it. I don't like it too much. Most all my welding I use the hard rod on. So the hard rod you use where you got to machine stuff. So this has got to be machined, so we use hard rod. Hard rod is kind of like cutting steel. It's got these good surface finish, got good strength. It's hard to tap, just normal stuff. When you're doing like fins and stuff like this is where you use 40-43 because it's just easy to work with. Like I said, it's not as you're using. It doesn't really matter if it's kind of semi-gummy on that. You just kind of work around it. So it's a good place to use that. But a lot of times I just use hard on that too. I don't care. Not much difference. When you got cracks you got to deal with, like this head when we heat it up, there's a crack right here. There's another little one. I think it was on this one. There's a little crack right there. Nothing major. It doesn't crack all the way through. It's just right here, right on that corner. This one here was cracked through here, and then there's a little bit of crack on the other side over here. So this port's really thin up under here. So they crack real bad through here when you put seats in them or stuff like that. This looks like a stock Harley seat, so I'm assuming it's just detonation doing it, overheating. That's why they crack through here also. So, and over here I put that real hard rod in there, which is this 55, 56 stuff. So it has, it cracks really bad because it's got a lot of a mag in it, I think is what it was. Makes it do it or something. Ceramic, I don't know, some stupid thing in there. Anyway, it cracks a lot when you get temperature, but it's really strong. So that's stronger than the other rods. But when you're trying to weld like this stuff where it wants to keep cracking on you, it doesn't crack as bad as this rod here. So this one here is more crack resistant like the 40-43. The 40-43 is a little bit less, but not much. So this is pretty crack resistant. This stuff here likes to crack when it shrinks, when it cools down. So it's all about the shrink ratio and stuff like that. So on this one here, I put the hard rod, that real strong stuff right here, because it is the strongest rod. So basically I put a cap over the crack that was on this side. There's a little small crack. Didn't go very far. So hopefully that'll stop it from cracking all the way through. I'll go in there and beat this all out and machine it so that we can put our intake clamp back on there. Because you can't weld aluminum to steel, so if you start to grind this out and try to work in it, you're gonna have, you got steel here, you got brass here, and aluminum, everything else, and you can't, they don't stick. None of those three things stick to each other, so makes it hard to deal with it. So like I said, you got hard here, super hard here, and use soft on all these other places. So that's the differences. So this one here, I'm going to have to figure out how I want to weld it and shrink it, make it work. This is a motor mount area, so I want some strength through here, so I definitely want to put hard rod in through here for strength. And I don't want this to re-crack. If this starts cracking going this direction here, it's going to be we're going to be fighting it really bad. I'll probably be in there with soft, and I got to keep the case really, really cool. Get in there, weld it, get the hell out of there, and you probably tap it with a steel hammer so it expands the aluminum as it cools. You peen it, and it'll expand it back out so it doesn't shrink too bad and doesn't crack. It's one of the tricks you do. The problem is if you hit it too hard, the material is kind of soft when it's hot, so you actually blow the whole backside out. I've done that more than once. So I give you these big cracks like this. You know, you would peen it right here around where you welded it, and if you hit it too hard, it does this on the inside. It spider webs it, everything. So you got to V that all out and re-weld all that. So it kind of defeats the purpose of doing it. So you got to be careful. So anyway, that's what we got to do. So I'm going to figure out how we're going to do this. So I know I got to get in here and weld it. So to V it out, you got to V it out fairly deep. You usually want to take about 3/4 of the metal out. And then when you put it back, it'll be nice, strong, 100% weld all the way through. Doing a cosmetic weld on top is not going to help you. It's going to come back and break. So I'm going to figure out how I'm going to. I got to figure out what I want to weld first. I really want the two cases to be together so I can keep everything square as I can. So this crack, I only see it on this side. I don't see it on this side. See, there's no crack going around that way. So there's a little bit right there. It's a little bit of hairline right there. You can kind of see a little bit right in there. So most this crack is mainly on this side, so I'm going to V it out on this side. So I'm thinking what I'm going to do is I'm probably going to weld this first, right here. And then I'll see how much this pulls in. And then I'll come back and V all this stuff out. I'll probably do this in sections. So I want to be able to bolt this case together to keep it equal and square. So I'm definitely going to weld this one last here. I'm going to weld it on this side first and try to keep it as straight as I can. And I'm going to V out this one also here on this side. So I'm going to V it out this side first, weld this side, and I'll come back over here and V it out from this side later after I weld it. And then I'll cut it down until I see the weld. And that way I've got 100% penetration. No doubt about it. Like I said, this one here, when you put heat to it, we'll see if the crack goes this way. If it does, we got major issues. So we're going to weld it on this side here. This will be bolted together on that case. And if I see the crack going around, then I'll V it out over here and I'll start welding from this side and try to get to stop cracking on this side. And I'll flip around later and do a weld the other side, and hopefully it'll bring it back to where it's still straight. Alright, so that's what we're going to do. And I'm probably not going to weld it tonight because it's getting late. But I might do one weld. So I'm going to go ahead and do some grinding and see what happens. So for tip dip, I use a nozzle dip for my wig welder. This one's blue. My old video had red. I don't know where that container's at, so I'll find it someday. It's hidden somewhere. So you take your grinder and you stick it in there, and that lubricates it, and it'll cut and not load up. So these are your two different cutters. You got a double cut for harder materials, and then for soft aluminum you got the single cut and coarse. So use this for hogging stuff out, and this is more for finish work. So they both work. So I got that in multiple sizes. See the same thing? And I keep one bit per grinder so I don't have to change out my bits all the time. Saves a little effort. Okay, so I'm going to do a little V in here, see what we got. So we got to work with here. Okay, so We're going to start by V'ing this out because this was only cracked on this side. So how am I going to hold on to this case? That's going to be the problem. No real way of holding it. Let's see here. Somewhere I had a big block of, oh there it was. Wood wheel cock for the truck. Don't need a trucks anymore, a trailer, so I'll use it for welding. A 2x4 into there. Short piece. Okay, that's halfway stable. You can't weld it with the wood, but you can do the grinding with the wood. So it's all mocked. It's all on here pretty hard, so locked in. Now it's going to move around once I start grinding on it. So I'm going to go ahead and V this out right here, and we'll see how deep that crack is. I'll probably weld that right now to start case welding. All right, let's see what this does here. It has a little bit wider nose on it than this one, so I'm going to switch over to this one and see if it works better for what I need. Load down, who's ordering? Pretty thick in there. It's like over half-inch thick. Yeah, blowing right in my face. All right. I got sawdust in my face. I don't know where all that came from. It's growing on me. Snowflakes. Bad dandruff. All right, so there's all V'd out. So the crack kind of went this way instead of where that was. But so right here, it's relatively thin right through here. Let's see right here, all of a sudden it steps way up in thickness right here. So you see how it gets really, really thick through here. So I don't see the crack going deeper, but it's probably, it might be in there, might not be. So when you start welding the bead and you get the puddle going, if there's a crack there, it'll be right through the whole puddle. So you keep heating until the puddle all of a sudden squeezes up on you, and that means you got the whole crack welded. So it's, without seeing it, it's hard to explain that, but that's how it works when you're welding on it. Now right now we got a little bit of oil and stuff on here from the grinder, which I don't like. So you can see all the old residue on here. So I'm going to go throw that in the blaster real quick and blast that area clean. And then we'll come here and start preheating that, and I'm going to weld that right now. We'll be back.